In this video, we'll set up a SureServo in position register mode and use a push button to initiate predefined moves. This is using the indexing capability of the drive. Up to 8 pre-programmed positions or registers can be defined, and you can specify relative moves or absolute positions. We'll assume that you have already jogged the motor as shown in the earlier video. At this point, power, fusing, and an e-stop contactor should all be wired appropriately. See Chapter 3 for wiring information. The motor code in P131 should also be set to the correct motor type. With the power off, we'll add the zip link cable and terminal block I/O breakout module to our setup, and a push button box. In this example, I've wired a 2-position servo enable switch, a momentary fault reset button, a momentary trigger button, and 3 maintained position selection buttons. The I/O can be powered by external 24 volts, or you can use the limited 24 volts available on the drive. For this example, we'll use the drive's 24 volt supply. If your application is more complex, you should consider an external 24 volt DC power supply. To use the drive's internal 24 volts, you need to add a jumper wire from VDD to COM+. To use external power, you should wire 24 volts to the COM+ connection and negative 24 volts to the COM- connection. Here is a schematic that shows our connections. For all the buttons and the switch, I've wired one leg of each to the COM- connection. The switch is then connected to the digital input 1. This will be the servo enable. The black momentary button is wired to digital input 5. This will be the alarm reset button. The green momentary button is wired to digital input 4. This will be the trigger to actuate the moves. The 3 maintained buttons are wired to DI2, DI3, and DI8. These will be used to select from 8 predefined positions. In each case, the push buttons will ground the input whenever they are pressed. Now let's configure the drive. Set the control mode first. P101 selects the control mode and direction. 0001 will result in PR mode, that's position mode using the internal registers, with the motor spinning counterclockwise as forward. The second most significant bit sets direction. I'm going to use a setting of 0101, which will also result in PR mode, but with the motor spinning clockwise as forward. Configuring the basic digital inputs. Select which digital inputs your system will require. Here is a list of P210 through P217 to help you configure the drive. A minimum configuration should contain at least servo enable, alarm reset, and the clockwise-counterclockwise limit switches if your system has overtravel limits. For our example, we will permanently disable the overtravels, P215 and 16, by setting them to 000. Please take the time to wire overtravel limit switches for safety or to protect your machinery, especially if mechanical interference or conflict is possible in your application. Configuring the position selection inputs. The drive can be configured to select the internal position set points by using 3 digital inputs, POS 0, POS 1, and POS 2. Any of the digital inputs can be set as POS 0, that's code 11, POS 1, that's code 12, or POS 2, code 13. By configuring all 3 inputs, all of the 8 internal presets can be selected via external signals. We have wired our push buttons to inputs 2, 3, and 8, so we will need to set up those inputs internally in the drive. To configure digital input 2 as POS 0, P211 will be set to 111. To configure digital input 3 as POS 1, P212 will be set to 112. And to configure digital input 8 as POS 2, P217 will be set to 113. To save digital inputs for other uses, not all of the position selection inputs have to be configured. If only 2 set points are needed, for example if the motor needs to move and then return, only one position selection set point needs to be configured. Configuring only one input, 2 for example, with pos 0 and pos 1 not assigned, would allow the selection of position 1 and position 5. We also need to set digital input 4 to be the command trigger by setting P213 to 108. This trigger will actuate the movements. One additional note about the digital inputs. The most significant bit selects normally open or normally closed. We've chosen 1 or normally open for all of our inputs, except the overtravels. Overtravels are generally wired normally closed as a failsafe. Parameter P133 selects incremental or absolute position mode. Enter a value of 0 for absolute mode or enter 1 for incremental mode. We'll start with 1 for incremental or relative moves. Remember to cycle power to the drive after configuring the drive I/O so that your changes will take effect. Configuring the position set points. Parameters P115 through P130 determine the set points of positions 1 through positions 8. Each set point can have 2 parts, full motor revolutions in the first register and an additional number of pulses in the second. So to move the motor exactly 1 revolution, place a 1 in the first position parameter, P115, and leave 0 in the second, P116. Let's set position 2 to exactly 3 1/2 revolutions. Set P117 to 3, and because one motor revolution consists of 10,000 encoder counts, set P118 to 5,000 to achieve 1/2 a revolution. Let's set position 3 to be 1/4 of a rev. Set P119 to 0 and P120 to 2,500 encoder counts. Let's set position 4 to be 25.4 revolutions. Set P121 to 25 and P122 to 4,000. Finally, I'm going to set position 5 at 100 revolutions even. Here is a list of the positions that I have selected. Feel free to select your own positions. You can set the remaining 3 positions, P125 through P130, to any values you choose. Okay, double check your wiring and review the parameter settings. We should be ready to test our setup. I'll power up the system and switch the servo enable on. The motor enables. Without setting any of the address lines, I can press the trigger and get 1 revolution of the motor shaft. This is position 1. Since we're in relative mode, I can press it repeatedly and get exactly 1 revolution each time. If I toggle the pos 0 input to select position 2 and hit the trigger again, the shaft rotates 3 1/2 turns exactly. Selecting position 3 yields 1/4 turns per trigger. Position 4 generates the 25.4 turns that we programmed, and selecting position 5 results in a long 100 revolution move. That's the basic position mode functionality. You now have a servo system set up for 8 predefined moves. Let's take a look at a couple of additional functions. We've programmed the system for 8 relative or incremental moves. What about absolute mode? Let's set P133 back to 0 for absolute position mode. Now the position set points will all be relative to the home position of the motor shaft. In our example, home, or 0 position, is the position where we powered up. The SureServo supports several types of homing routines. Reference the manual and parameters P147 through P151 for more information. We'll cycle power and test our position commands again. If I now select the pre-programmed position 3, the shaft will rotate 1/4 of a turn. Pressing the trigger again does nothing because we are already at the specified position. Selecting position 1 will now cause only 3/4 of a revolution of movement to reach the 1 revolution set point. Selecting position 3 again now results in a reverse move of 3/4 of a revolution, back to the absolute position of 1/4 turn. The SureServo also supports automatic positioning with either absolute or relative moves, with preset dwell times for each position. In this entire example, we've been using the default speed and acceleration values in the drive. The SureServo allows a separate velocity value for each of the 8 moves. Separate acceleration and deceleration values are shared for all the moves. The drive even supports S-curve acceleration and deceleration for smooth starts and stops. See parameter P136 for more information. Let's increase the speed of a move and slow the acceleration. I'll increase the speed of position move number 5 by changing P2-40 to 3000 RPM. The default was 1000. I'll slow the acceleration time, P134, from its default value of 200 milliseconds to 2000 milliseconds. And again, let's test the move. You can see the dramatic difference. The shaft accelerates slowly, but gradually reaches a higher speed.